For the last year or so, there's been this invisible wall in the AI space.
Yeah, there really has.
Right. So on one side, you have the closed gardens, GPT-4, Gemini, Claude, the massive, expensive model sitting behind an API. They're smart, they're polished, but they are complete black boxes.
Exactly. And then on the other side, you've got the open source Wild West, LMO, Mistral, all the models you can actually download and tinker with yourself.
And the unspoken rule, the rule for you and me and everyone else following this space, has always been that the open models are, good for an open model.
Right, it's the AI participation trophy. We celebrate them because they're accessible, but nobody seriously expects a model you can run on your own server to outthink the trillion-parameter giants.
Or at least that was the rule.
Until this week.
Exactly. Databricks just took a sledgehammer to that wall with their new model, DBRX. And honestly, reading through the technical report for this deep dive, this doesn't feel like just another iteration.
No, it feels like a changing of the guard.
We aren't talking about catching up anymore. Databricks' headline claim is that this new open general-purpose model actually sets a new state-of-the-art. They're actively beating GPT-3.5 and giving Gemini 1.0 Pro a real run for its money.
It's a bold claim, but the measurements they published are backing it up. And our mission today is to unpack exactly how DBRX works, because this isn't just about raw power. It's about a specific shift in architecture.
Right. We really want to dig into why its mixture of experts architecture is different from the others, what this means for efficiency, and basically what this shift means for the future of open source AI.
Yeah, because DBRX is proving that granularity can actually triumph over sheer density. They didn't just build a bigger brain, they built a more specialized one.
So let's get under the hood. DBRX is a transformer-based, decoder-only LLM.
Which is standard table stakes right now.
Right. But the key is that mixture experts or MOE concept. I think MOE is becoming a buzzword for a lot of people, but the nuance of how DBRX does it is where the magic actually happens.
Well, let's define the baseline first. If you run a standard dense model, say a massive 132 billion parameter dense model, every single time you ask it a question like, what's the capital of France? It has to fire every single parameter to give you the answer.
It's like mobilizing the entire U.S. Army to open a jar of pickles.
Exactly. It's incredibly wasteful. So MOE changes that calculus. It breaks the model down into specialized subnetworks, which we call experts.
So for DBRX, the stats are fascinating. It is a 132 billion parameter model total. In the open source world, that is an absolute behemoth.
It is, but here's the critical distinction. For every token it generates, it only activates a fraction of that size.
Only 36 billion active parameters at any one time.
Right, so while it has 132 billion parameters of knowledge stored up, it's only using 36 billion for active inference.
Which explains why it feels so fast. But MOE isn't new. Mixtral did it. Grok 1 did it. What makes DBRX's approach fine-grained? Because that's the term they keep throwing around in the paper.
It really comes down to the ratio of experts. This is an engineering trade-off that is incredibly difficult to pull off. Most previous MOEs, like Mixtral or Grok 1, settled on a pretty standard architecture. 8 experts total, and you pick the top 2 for each token.
Okay, so you have a committee of 8 people, and for any given problem, you ask the 2 smartest people in the room to handle it.
Right. It's a safe, stable balance.
Mm-hmm.
But Databricks looked at that and said, not granular enough. They doubled the expert count to 16.
And they doubled the active selection to 4.
Exactly.
So now I have a committee of 16, and I'm consulting 4 of them. Mathematically, that sounds like a nightmare for the router.
Oh, it is. That's why not everyone does it. The routing algorithm, the piece of code deciding which 4 experts to pick out of the 16, has to be so precise. If it's slightly off, or if it just lazily biases towards a few experts, the whole model degrades.
But the upside is massive, right? By moving from choose 2 of 8 to choose 4 of 16, the number of possible expert combinations just skyrockets.
It goes up by about 65 times.
65 times more possible combinations. That's the aha moment for me. It's not just about having more experts. It's about the combinations allowing for much more subtle nuance.
Exactly. Instead of just handing a query to a broad math expert and a broad English expert, you might route a complex physics word problem to the math expert, the logic expert, the academic writing expert, and the technical vocabulary expert all at once.
It creates this fine-grained expertise that dense models just struggle to replicate unless they are 10 times the size.
And the research team explicitly credits this architectural choice for the massive boost in model quality.
Before we move off the architecture, we should briefly mention the technical specs they used. They included rotary position encodings, or ROPE,
Yep, gated linear units, GLU,
grouped query attention, GQA, and they used the GPT-4 tokenizer.
which is a very solid modern recipe.
Right.
But let's look at the scoreboard, because this is where the David versus Goliath narrative really kicks in.
Yeah, let's talk benchmarks. Who is DBRX actually fighting against?
Well, in the open weights corner, you have LMA270B, Mixtral, and Grok 1. And in the closed source corner, you've got GPT-3.5, Gemini 1.0 Pro, and Mistral Medium.
Usually when a company releases a state-of-the-art open model, they cherry-pick the benchmarks. They'll win on one obscure test and claim victory. But looking at the Hugging Face Open LLM leaderboard and the Databricks model gauntlet, DBRX Instruct is leading on composite benchmarks.
A very consistent performer.
The one that really caught my eye was the programming score, the HumanEval benchmark. DBRX hit 70.1%.
Which is huge.
Yeah.
For context, Grok 1 is at 63.2%.
And Mixtral is down at 54.8. But here's the absolute kicker for me. It beat Codalame 70B.
That is the most significant data point in the programming section. Codalamo is a specialist. It was trained specifically to write code.
It's like a general practitioner outperforming a heart surgeon at heart surgery.
And it really validates the MOE thesis, doesn't it? If your coding experts within the general model are good enough, and your router is smart enough to activate them at the exact right time, you don't need a separate specialized coding model.
The generalist becomes the specialist on demand. And it's not just programming. It outperforms Grok 1 on math benchmarks, too.
Which is wild because Grok 1 is approximately 2.4 times larger in terms of parameter count.
So it's punching way above its weight class in the open world. But the big reveal is how it does against the closed models. DBRX Instruct generally surpasses GPT 3.5.
Which is a massive psychological threshold to cross.
We're seeing specific wins with higher scores on general knowledge, the MMLU benchmark, and common sense reasoning, which is hella swag. And as we mentioned, programming.
It's also highly competitive with Gemini 1.0 Pro and Mistral Medium.
You know, it feels like we've reached a point where open source is no longer a compromise on quality for the sake of control. You are getting the control and the quality.
Which has to be terrifying for the closed model vendors.
Yeah.
Their moat has always been, sure, we're expensive and secretive, but we are much smarter. If that gap vanishes, the value proposition of a closed API starts to look pretty shaky.
Especially for enterprise use cases. And speaking of enterprise, let's talk about the efficiency paradox. The tension in AI has always been that bigger models are smarter, but slower and more expensive. Smaller models are fast, but kind of dumb.
Right, but the MOE architecture breaks that trade-off. Because DBRX only uses 36 billion active parameters, it is fast.
How fast?
It creates text up to 2 times faster than Llama 270B.
Even though a Llama 270B is a smaller model on paper.
Exactly, because Llama has to use all 70 billion parameters for every single token. DBRX only uses 36. So on Databricks serving platform, they're seeing throughput reach up to 150 tokens per second per user.
150 tokens per second. I mean, human reading speed is maybe 5 to 10 tokens per second. This thing is generating text vastly faster than you could ever consume it.
It's essentially instant for a user.
Yeah.
But where that really matters is for batch processing and training.
Right. Let's talk about training efficiency. Training these massive models is an environmental and financial undertaking.
Databricks actually found that training MOEs is about 2 times more FLOP efficient than dense models for the exact same quality.
They compared it to their previous model, the GPT-7B, right?
Yeah, the new DBRX recipe creates similar quality with nearly 4 times less compute.
4 times less compute is a massive cost saving. Although, looking at the hardware they used for DBRX, it's still an astronomical scale. This was 3,072 NVIDIA H100 GPUs.
Connected by 3.2 terabit per second InfiniBand.
Getting your hands on one H100 is hard enough. Linking 3,000 of them together is an incredible flex. It's Databricks saying, we have the infrastructure, and it took them 3 months to run this process.
But the hardware is only half the fuel. You can have all the GPUs in the world, but if your data is garbage, your model is garbage.
Right, the data set. DBRX was pre-trained on 12 trillion tokens of text and code. 12 trillion.
It's a staggering amount of information. But Databricks emphasized quality over quantity here. They estimate this data is at least 2 times better, token for token, than the data they used for their previous MPT models.
And they used a technique called curriculum learning.
Yes, which means changing the data mix during training to improve quality. You don't just throw all 12 trillion tokens at it randomly. You structure it. Maybe focus on foundational knowledge first, and then introduce high-level coding later in the run.
It mimics how humans learn. You don't give a kindergartner a calculus textbook.
Exactly.
And I think it's worth pointing out the tooling they used. They used the standard Databricks tools that are available to their customers.
Unity Catalog for data governance, Apache Spark for cleaning, MLflow for tracking, and Mosaic AI for the actual training.
It's the ultimate proof of concept for their own platform. They're showing customers, hey, the tools you rent from us are the exact same tools we use to build a GPT-3.5 killer.
It's a brilliant marketing move, honestly.
So we have this highly efficient, incredibly smart model. Let's pivot to how it handles context and retrieval, because this is where a lot of business value actually lies.
Right, RAG, Retrieval Augmented Generation.
Exactly. DBRX has a context window of 32K tokens, which is solid, but context window size doesn't matter if the model suffers from the lost-in-the-middle problem.
This is a huge issue with long context models. They can remember the very beginning of your prompt and the very end of your prompt. But if the crucial piece of information is buried right in the middle of a 20-page document, they just glaze over it.
Databricks ran tests specifically for this, and DBRX Instruct generally performs better than GPT-3.5 Turbo at all context lengths when finding that hidden information.
Which is critical for businesses. When you're connecting AI to your own proprietary data, say, dumping a massive compliance manual into the prompt, you need it to find the exact rule on page 87.
If it misses it, that's a liability.
And on standard reg benchmarks like natural questions and hot pot QA, DBRX is highly competitive with GPT 3.5 Turbo and top open models like LMA270B.
It's a workhorse. So just to summarize where we are, DBRX represents a major shift. Open models aren't just catching up. They are actively beating established closed models like GPT 3.5, particularly in coding and math.
And they are doing it with unprecedented inference efficiency, thanks to that fine-grained MoE architecture.
The weights for both the base and instruct models are available right now on Hugging Face. And of course, the model is available via API for Databricks customers.
It really makes you rethink the trajectory of the whole industry.
It does. And I want to leave you with a final provocative thought based on all this. If a fine-grained architecture with 16 experts allows an open model to beat GPT 3.5 with greater efficiency, what happens when the open source community pushes this to 32 experts?
Or applies it to even larger, more refined data sets.
Exactly. Are we witnessing the exact moment where open architectures permanently outpace the efficiency of closed, monolithic models? It's something for you to mull over as the AI landscape shifts yet again.
It's going to be a very interesting year.
Thanks for joining us for this deep dive.
Thanks for having me.
We'll see you next time.